Here at Team BRIT, we're world leaders in disability motorsport. And what that really means is that we take engineering and technology and we use that to enable disabled drivers to compete internationally on a level playing field and win repeatedly against able-bodied drivers. Let's have a look at some of the technology that we've developed with that in mind. What we identified very early on in the beginning of the team was a requirement for much more advanced hand controls. Typically at the time, drivers who were using hand controls in race cars were using what's called a push-pull system. It's just a mechanical lever that goes on the brake and the throttle pedal. So you push for brakes and you pull for throttle. What that means is that the driver's only got one hand on the steering wheel because they need one hand on the lever at all times. It also means the driver hasn't got access to a gear shift system. They can't use the paddles on the back of the steering wheel, and they certainly can't use a normal H-pattern gearbox. In order to control a race car effectively and at speed, and to not be at a disadvantage against able-bodied drivers, the drivers need to have all of the controls accessible on the steering wheel at the same time. So that means that they need to be able to brake and throttle, they need to overlap those controls, shift gear and steer on full lock to full lock, all at the same time, to be able to control the car effectively and safely. So we set about designing a system that put all those controls on the steering wheel, that put those controls right in front of where the driver needs them so that they can win races. We started very early on with a system like this. This was, I think, version 1 of our steering wheel. We kept the gear shift on the back as you would with a regular paddle shift system. So gear up and gear down, and the throttle and brake were put on the front of the wheel. So the drivers would use their thumbs here, throttle and brake, to control the car. We also had the addition of a clutch lever, so we could use this car with a manual gearbox if we needed to. This worked okay, this was good, but from an ergonomics point of view, the drivers were really struggling on the longer distance races, and that's certainly where our drivers wanted to head, into the endurance racing space. So we then progressed and we went through various design iterations of testing position, location and feel for these paddles on the steering wheel. And ultimately we've ended up with what I think is now version 7 of our steering wheel. This is the current wheel that we use in our race cars. There's definitely a few design advancements from the earlier wheel, but the main one really is the position of where we've got these paddles on the steering wheel. So we've got the throttle and the brake on the back. These give the driver full control while they're going around corners like this. We've also got gears on the front. So we've got gear up and gear down on this side. We've also got the same control for the gears replicated on the other side. So gear up there and gear down there. This means that these controls cater for a real wide range of disabilities. So we have drivers, for instance, that have the use of one arm and they can use the pedals as they would ordinarily in a car, and they can go gear up and gear down on the side that they can use their arm. We also have drivers who perhaps are paraplegics, they don't have the use of their legs, so they can choose to use the throttle and brake on the back of the steering wheel, and they can gear up and gear down wherever is appropriate for them. Ordinarily that would be throttle on the right paddle and gear up on the left, and then the inverse in braking, so you're on the brakes on the left hand paddle and gear down on the right hand side.
My name's Aaron Morgan, I'm 33 years old and I'm from Basingstoke. I get to drive the Team BRIT McLaren 570S GT4. My love for motor racing started when I was 7 years old. I began motocross racing. I just love the competitiveness, the speed you can get up to, all the cool stuff you can do being on the track. And I just love the feeling of being on the edge of the limit, if that makes sense. So where the car is sliding and moving around underneath you, but just enough so you can keep it on the black stuff. I'm a paraplegic at T6 level, which I sustained through a motocross crash when I was 15 years old. Being part of Team BRIT means an awful lot to me, where when we're in the garage together, there's a sense of feeling disabled. Everybody is the same, so you all share that one identity. We all have a great laugh in the garage together, and we're able to, like I say, we're able to have a great laugh together, but we're not judging each other. And we're always helping each other and pushing each other along in our driving ability.
Over the years, there's been a few really specific requirements for hand controls. More recently, that's taken the form of some tetraplegics that we've been working with in order to allow them to control a car effectively. Tetraplegia is where you have a spinal injury that also affects not only the use of your lower body, but in some way the use of your hands. So they don't have the fine resolution of control needed to control a car using paddles like this. Tetraplegics do often have a fine resolution of control in rotation of the wrist, and so we developed these controls here. This is just a prototype that we proved out on the simulator, but it enables drivers to throttle and brake as they're driving around the circuit. The thing that you can clearly see is missing from this is a gear shift, and so we use a sit puff system for the gear shift in this instance. So there's a tube that sits inside the driver's helmet, and they can suck on the tube to shift up and blow on the tube to shift down. This again gives tetraplegics a full range of control. We've also been working with communication systems. So it's not just the ability to control the car that's important in a racing situation, it's also important for drivers with communication disabilities to be able to communicate with the pit wall, to be able to communicate with their engineer during the course of a race. And so more recently we've developed a system that interfaces with a cochlear implant. That means the engineers on the pit wall can use the voice communication system to talk directly to the driver's cochlear implant system. It also means that we can feed audio feeds into that system, so the driver's got more of a sense of what the car's doing in terms of engine revolutions and how the tyres are sounding to them.
I was born hearing, and then I had an ear infection. When I was 2, I think I started to have operation. But I started on hearing aids, and then up till 4, I started having processors, cochlear implants. So that's how it makes me hear things and have a conversation with people and communicate anything. Can do anything like other hearing people. Team BRIT is giving me a very good opportunity to go on the next level of motorsports, and hopefully in a future time I'll be in a GT4s.
In terms of the development of the ergonomics of these wheels, we've got a couple of really useful tools at our disposal. Chief amongst them really is the 3D printer that allows us to rapidly prototype any of the changes that we want to test. But we can also use these in the environment of the simulator rather than putting them on a live race car. So we can rapidly go through various different iterations of a design and allow the drivers to try them out in the simulator environment and find out really what works well for them. In that simulator environment, we're aware that different drivers have a different capacity for various different lap times. And so for us, the key metric that we're looking at is just that lap time. Are we going quicker with these versions of hand controls, or are we going slower? Is the driver more comfortable or less comfortable? And so being able to do that in a safe environment is absolutely critical. Once we're comfortable with the design changes, they can proceed to production, and then we can get those parts out live on a racetrack with the driver. It's been fantastic to see our drivers over the years achieve pole positions, race wins, and even championship wins using these hand controls. And being able to enable them to go out and win against able-bodied competitors has been a really powerful thing. Over the years, we've probably helped in the order of 100, 150 disabled drivers get through this process. And over 50% of the disabled race licence holders in the UK have come through our doors. Looking to the future, we're always looking to improve the technology that we're using here. We're currently working on some systems to provide some haptic feedback on the braking here, which we hope will really enable the drivers to push deeper into the braking zones. The overall goal of the team is ultimately to be the first all-disabled driver lineup to race at the prestigious 24 Hours of Le Mans. So that takes us through how and why we've performed some of these adaptations for the drivers on our race cars. Check out our next video to see more detail on the 3D printing side of stuff and prototyping. Don't forget to like and subscribe for more engineering insights.